via the chat?
Well, we're monitoring the social media, WeChat and WhatsApp groups. So
yeah, I'll cover
also
as well.
Yeah, put your stuff in, put your questions in there.
Yeah, so if you are going to engage, a good solution might be to open up your WeChat or your WhatsApp account if you've already connected to us. I don't see the number of participants here, Mark.
No, 24,
Okay.
25, but I don't think that's right.
25 is not a number though. Okay, I'll wait for your nod, Mark, as to when to start.
Okay, well, we'll be recording the session, so if you want to revisit, that's okay. But yeah, I think we'll go, Michael.
Should we go? Okay.
Let's go.
Okay, great. Well, good afternoon, everyone. Welcome. So the idea of today's session, as indicated on the slides, is to give you, well, in part, we're going to look to answer a few questions about what this digital and data science, or DDS, specialism is all about. Okay, so I've got the Q&A open, so please do post away. But also we wanted to actually make it a representative sample session to give you a feel for how a typical class might be. Now, obviously, this is much smaller than your typical class and obviously shorter, and we are a little bit more limited by the technology than we would be if we were running an online class traditionally. Because this Teams Live, as Mark talked about last week, it's a little bit more one way than the Teams we would use in a classroom, but we are going to give it a shot and see how it goes. So, as I say, two main agendas today. One is to give you a bit of info and a bit of a feel for the DDS specialism, but we're also going to look at a particular topic, and the topic we're going to look at today is a topical one, perhaps a bit of a risky one, but you know, that's the way I like to live my life. We're going to look at the question of how do you solve a problem like COVID-19 using digital and data science. So we're going to have a short bit of content here at the start where I will be lecturing at you. This is me lecturing at someone else, so I'm going to be doing that in an online fashion right now. We're then going to try to run a seminar session, so hopefully you can get involved and post your ideas, and we'll look to work collaboratively on a project. And then thirdly, we're going to give you some insight into the specialism. Lipping's going to lead that part and hopefully answer your questions and help you understand if this is the right choice for you. As already mentioned, and I see some of you have already engaged in, we would like you to get involved. There is the live event Q&A. One of the limitations, as I understand it, of this Teams Live interface is that there is a slight delay when using Teams Live. So when you post something, I think it's about 30 seconds before I see it, and when I ask you something, it'll be 30 seconds before you actually hear my question. For that reason, you may prefer to, rather than using the Q&A, use one of the social media apps. So in particular, we have the WeChat group. I know quite a lot of you have already joined that group, so feel free to engage and ask questions via that, or alternatively, the slightly less popular WhatsApp group. So if you are in either of those, we are monitoring them throughout this session, so you can post your questions in there, you can engage in the seminar part in there. So I've already basically said this to you, but what we're going to be looking at, my short lecture content, really is just a rant, some observations I've had watching the way that data and statistics have been presented and used during the COVID-19 pandemic. Spoiler alert, there's been lots of issues and it's not been great. We're then going to do a collaborative seminar work where collectively we're going to brainstorm and we're going to create a new, or the design of a new COVID-19 data product. We're going to save the world with our data science brains. And then Lipping's going to take over from me and talk a bit about the DDS specialism, the modules, and most importantly, whether it is right for your interests, essentially. John's here. Okay, so starting the lecture piece, as we've probably all seen, there have been all sorts of digital products created and used, and a big part of governments all around the world's efforts in dealing with this pandemic has been the use of digital science, the use of digital apps in particular. So these two in the picture are Google and Apple's collaborative app designed to help trace and contact trace people who have the virus and the contacts that they've made. So we've seen all sorts of things like that. I won't go into it here, but the way the UK government tried to build their own and then gave up on that was particularly shambolic, but there we go. We've also seen all sorts of websites built and booking for coronavirus tests is the example here, but there's been a variety of different websites built by governments and medical groups in order to communicate and inform the public. And we've seen a whole heap of web-based dashboards. This one's for you, Armagan. This is the Pakistan government's coronavirus dashboard that talks about numbers across the country. Alongside that, data science has been a big part of the effort to contain this pandemic. So we've all suddenly learned about the value of logarithmic scale graphs, such as this one. And people, non-statisticians and non-data people the world over have been obsessing about charts and understanding growth rates. And the catchphrase in this country, I don't know how international it was seeking to flatten the curve to go from exponential growth to steady growth or even decrease. And also we've seen a whole bunch of modelling, which I'll come on to later, a whole heap of data science teams and universities. And I even have helped, volunteered on one such effort, have been used to help model and predict what will happen next and identify problems, both in the medical space. So obviously there's been a whole heap of medical research into new drugs and into new treatments, and also into just understanding the virus better itself. But more interestingly, perhaps from a DDS perspective, there's been a lot of research into forecasting growth in different areas and planning intervention strategies. However, I think I've already given you the spoiler. Certainly in this country, the use of statistics, particularly in the media, has been questionable at best, as this rather angry statistician is about to tell us.
They're now very familiar with these daily press briefings. How well are they working, do you think?
Well, I watched yesterday's, and frankly, I found it completely embarrassing. We get told lots of big numbers, imprecise numbers of tests being done, 96,878. Well, that's not how many were done yesterday. It includes people that were posted out, tests that are posted out. We're told 31,587 people have died. No, they haven't. It's far more than that. So I think this is, actually not trustworthy communication of statistics. And it's such a missed opportunity. There's a public out there who are broadly very supportive of the measures. They're hungry for details, for facts, for genuine information. And yet they get fed this, what I call number theatre, which seems to be coordinated really much more by, a number 10 communications team, rather than genuinely trying to inform people about what's going on. I just wish that the data was being brought together and presented by people who really knew its strengths and limitations and could treat the audience with some respect.
Yeah, so he was very angry about it. I'm not sure I quite got angry, but it has been quite an interesting experience watching a whole bunch of non-data people suddenly trying to deal with data. And I think not only does it give us some interesting things to talk about right here, but also it gives us a good illustration of what it takes to do data science and data science in the digital sphere well in businesses. And as the title suggests, what not to do. It's been an abject lesson in what not to do in many cases.
Now very...
So, first thing I wanted to talk about was one of the first sort of big stories that came out in this country. So I suspect many of you were looking around the world and saw the initial UK government response to the pandemic, which has been widely condemned and widely seen to be incorrect and insufficient. It did get better thereafter, But in that initial phase, there was absolutely mistakes made. History will not look kindly on the way the government handled it, but also on the way that the modelers and the statisticians, the data scientists, handled that initial phase. So a lot of the government's strategy was based on initial simulation modelling. So they were simulating what might happen with a whole bunch of different decisions. What would happen if we do nothing? What would happen if we close universities and schools? What would happen if we isolate vulnerable people? And so on. Now, what this highlighted, and where it went wrong, what it highlighted was something that people outside of the trade perhaps do not realise. A lot of people look at this kind of modelling and think, well, it's just mathematics, it's just data, therefore it must be accurate. When you are building these models, particularly when you're building models that are trying to predict the future, you have to make a whole bunch of assumptions. So when these guys were building these predictive models, they had to make assumptions about the way that people would behave, about how fast the disease would spread, about how many people would be going to hospital, what the mortality rate would be, and so on. About 3-4 weeks into the pandemic in the UK, the guys doing the modelling suddenly changed direction. They suddenly released an urgent article saying, hang on, we've got this wrong. Basically, they had made assumptions about what percentage of people would be requiring hospital treatment, and those assumptions then didn't match the experience in Italy. So Italy was a few weeks or months ahead of us. Once the Italy numbers started coming out, the guys who had done the modelling realised their assumptions were incorrect, that a higher percentage of people would be requiring hospitalisation than they had assumed. Once they plugged in those new numbers, it became quite obvious how catastrophic the current government strategy was, and promptly the government turned around. The point I want to make here is that these assumptions that we make in any model, any data science model, any statistical model has assumptions. We need to treat those assumptions carefully. We need to be more flexible and more what if about them than the government response was. Secondly, has been the parity of graphs and visualizations of data. So this is a graph from Alabama talking about the effect of COVID-19 and who's been infected by COVID-19 by different categories, by different age categories and by different ethnicities. Anyone want to comment on what is wrong with these graphs? Anyone have a view of why I'm going to be criticising these graphs? That can include staff. Any thoughts? Well, number one, they are shown as a pie chart, and as you will see over the course of the year, I have no love at all for pie charts. Pie charts are a very bad way of communicating information, and this actually gives you quite a good example of it. It is much clearer to me the difference between the black and the white communities based on these numbers. The fact that these numbers are here tell me what those differences are. Now imagine if those numbers weren't there. Would you be able to tell which part was bigger, black or white? The answer is no, because pie charts are very bad at communicating that information. Secondly, the second big issue with this one is they are not put at all in context. Let's look at an alternative from New York. So in New York, there's no graph here. They are just showing the raw numbers. But what they are showing is that there are the numbers in relation to what percentage of the population represents each group. So I happen to know that in Alabama is a majority white state. So the white population is more than 50%. Therefore, knowing this, we know that in Alabama, the number of white people who were infected was less than the number of white people in the population, and the number of black people was higher than the number of black people in the population. The way New York has presented it, it's become quite clear that Hispanic communities and black communities have been overrepresented in COVID-19 deaths, whereas white communities and Asian, in America, Asian means typically East Asian, are underrepresented. So by putting that context in, the information is much more powerful. Now, this all comes from one government presentation. We've had these daily government briefings where basically every single slide they presented was wrong and was very, very misleading. So this was when they wanted to relax when they brought about relaxation of the rules, when we felt that the number of infections and the R rate, the rate of infection, had got low enough that we could start relaxing the rules. But virtually every slide was wrong. So this was the first of them. This one says this COVID alert level. So they've created a COVID alert level that is 1 to 5, and it equals the rate of infection plus the number of infections. What is wrong here is that this suggests this is a numerical equation, right? It obviously is not. The number of infections is going to be more than 5. The COVID alert level only goes up to 5. Secondly, rate of infection is going to be a percentage sort of number. It's going to be, if things are going well, which they were at the time, it's going to be a number less than 1. So this number plus the number of infections, which is probably hundreds, is going to be completely dwarfed. The rate of infection will have no bearing on this, if indeed it is an equation, which it isn't. This was their second one. So I'm all for these kind of dashboard visualizations where we go from green to red, and we know that green is good and red is danger in this case. What messes this graph up is this number 1 up here. So it is well known that when the R rate is 1 or higher, the disease is growing, essentially, which is why this one is such an important thing. However, by putting 1 here, we are suggesting that each of these are categories related to an R rate of 1. Therefore, this boundary must be 0.66. This one must be 0.33. It doesn't mean that at all. So it's completely misleading. Even worse, going the other way, that would suggest that the R rate couldn't get higher than 1.66. And obviously we know that to be incorrect. Again, completely misrepresenting the numbers behind these values. We then have the same graph shown here, and bearing in mind that this was meant to be a presentation saying that things are good, things are improving, we're getting to be safe, essentially, right? So that's what this bit here on the right hand says. However, what does this bit on the left hand say? These little red dots are meant to show a number of cases in each of these areas. By putting red dots on the graph, straight away you are scaring me, right? Straight away you are saying something bad's happening in East Scotland, something bad's happening on the south coast in Brighton, right? You're straight away giving a message that there's a problem here. So we're getting completely mixed messages from the two visualizations. And here's the last one, probably the worst of all of them. So this is meant to be showing the forward plans. And there's 3 steps, 3 stages of easing the lockdown. Well, firstly, they could have been much more explicit about what these are. So step 2 is open. What is going to open at step 2? Are we talking about everything opening? Are we talking about just some things opening? It would have been far better and clearer to actually include the text of the things that you could do here. However, the bigger problem is that they decided to put this over our sloped graph. So our sloped graph is meant to show the falling rate of infection, essentially. We've flattened the curve, okay? These steps have nothing to do with the curve of infection. The rate of infection has nothing to do with these steps, right? As we know, we're using something like this calculation up here, right? It's nothing to do with this curve. So we're trying to mash 2 things together, and in doing so, we remove the meaning of both of them. Okay, here was another recent one. So this one was published in the last couple of weeks in the Daily Mail, which is the UK's equivalent of Fox News, if you know that one. So this is showing areas in the UK which have grown, where the rate of infection has grown. So the reason I was shown this was my wife happened to read it and called me in quite a panicked way and said, Michael, Coventry has gone up 120% week on week. This is a disaster. We should start panicking. Actually, that is very, very wrong. What is hidden in this graph is actually how many people were infected. We have this slightly nebulous thing of it going from 1.4 to 3, which is the rate per 100,000 population. But unless you know what the population of Coventry is, that is not a very useful number. So I actually dug a bit deeper. I went and looked at what the raw numbers are. So it turns out this first week, there was 5 infections. There was 5 reported cases. In week 2, there was 11. So yes, technically that is 120% increase. I am not particularly worried about 11 infections in a city the size of Coventry. Coventry is, I think, the 16th or 17th largest city in the UK, right? This 3.0 actually translates to 0.003% of Coventry is infected. These are low numbers. By focusing just on this percentage increase, we lose an awful lot of meaning. And in fact, some others on the list, there was one point on the list where they were showing the rate of infection had gone up 300%. It had gone up 300% from one case to 3 cases. Okay, again, 3 cases is not something we should be particularly worried about. Very misleading the way it's presented. Which leads us to an essential truth. I really liked this quote. It came from an article just this week. In the fog of pandemic, every statistic tells a story, but no one statistic tells the whole truth. There have been far too many people picking up on a single metric and saying, this means this. Because of this, this must be true. We have to look across all of the data and all of the metrics to really understand what is going on. So for instance, if you have a very, very low rate of infection, if you have a very low number of cases, if you have a number of cases of 1, right? Any increase on that 1 will show a really, really high R spread, right? It will show the virus is growing really quickly. However, if your starting point is really low, you shouldn't worry. The other way around, let's say the number of cases is really high. Let's say they're in the tens or the hundreds of thousands. Even if we have a low rate of infection, a low R rate, that is still something to be very concerned about. We need to look across these numbers, and too few in the media have been doing this. So the last thing I wanted to talk to you about in this session was error. So when we look at any of these numbers and when we look at any of these models, all of them will include error. Any statistical model, any data science model, any measurement will include some error. We are not getting ever exact numbers of anything. All we are getting is approximations, right? Whenever we have inexact measurements of this kind, you are going to get two types of error. You will get some random error. Some things will just occur slightly randomly out. So a good example of this is, so we've been watching the numbers in the UK and it's been going down and down and down, and over the course of every week it is going down to smaller numbers, right? However, in one given day, that number might rise. That is just random error. Not everything will exactly follow the trend. The bigger thing to pick up on this is that there is a lot of what's called systematic error. There's a lot of error that comes from various things. First of all, systematic error can come from the way the tests are actually done. No test is 100% accurate. So whenever we're doing this test, we're going to introduce some error in that way. But there's also been a whole bunch of error about the way numbers are collected and the way numbers are reported. So this is going back in time into really towards the peak of the crisis in the UK, early May. Actually, probably that's past the peak into the slightly better time. But this is very representative of many different weeks. So looking across a week, day by day across a week, we get this spike. These spikes occur on Wednesdays and Thursdays. Sundays, Mondays look really good. But Wednesdays and Thursdays, every single week, looked really, really bad. Any ideas why that might be? Is it because people don't die on Sundays or don't get infected on Sundays? Any ideas? I think this is the 30-second delay, so I will give you the answer. The reason why we saw this shape every single week is not as many people are working in the hospitals on Sundays. So on Sundays, infections and deaths weren't being recorded into the IT systems. They were being saved up. Where we have these inflated statistics on Tuesdays, Wednesdays and Thursdays, a whole bunch of these people were actually infected at the weekend or came to hospital on the Sunday. It just wasn't built into the system. So we need to understand that a whole bunch of these numbers are exposed to systematic errors. And again, that has just not been represented in our media presentations. So what should we do? Should we just give up on maths and statistics in this space? Is data science not a good fit? Not feeling exactly right, I know. Should we just give up on data science in this space? The answer, if you haven't got it from my meme, from my opinion at least, is definitely no. If we are going to get out of this as a world community, we will rely on data, we will rely on digital products. This will be the foundation of us building our way out of it, and also, you know, rebuilding the economy and building what will need to be a new world. Digital and data science will be at the very heart of this. Which leads us on to our seminar session. So in our seminar session, you are going to help me, or as a group together, we are going to design a new COVID-19 data product. So you may not have heard of this term, data product. A data product is quite a new term. It's particularly used in data science and AI communities. So the idea of a data product is this is a thing that we build that will take some data from different sources, will analyze it in some way, but it will then serve the results of that as a product that other IT systems or real people can use. So an online dashboard would be a data product. Things like Amazon's product recommendation tool is a data product. It's a product that is then used by Amazon's website. And that's something we are going to build together. Specifically, we're going to build a tool that is going to help us predict areas where an outbreak will occur. Will help us understand, is this particular region problematic? Do we need to send in the people with the testing kits, and do we need to impose mini lockdowns in different areas? That's the tool we're going to build together. And we're going to follow a data science process that looks something like this. First of all, we need to think about what data is there? What data is there in reality that will help us predict this? We then need to think about how we're going to process that data, explore that data, clean that data, and find the elements in that data that will be useful. Once we've done that, we're going to build a predictive model, and then our main goal with that predictive model is to serve it as a data product that can be used in the real world. So the steps in our process, in our simplified process, because we haven't got a great deal of time, are as follows. The first thing we've got to do as a group is identify what data we can use to run this, to fuel this data product. From that data, we need to know what items in that data are actually going to be useful. We're then going to think very quickly and very briefly touch upon a modeling approach. We then need to think about how we can test our predictive algorithms' usefulness. Is it actually working? And then finally, what application are we going to build? How are we going to serve this data product to the world? So let's start at number one. And I'm hoping you will help me with this, friends. And if not you guys, then maybe some of the staff in the chat. Let's think about, where can we get data? Well, I'm going to give you some obvious ones to start with. Records. So who's coming into hospitals? Who's reporting things? We might also have doctor records. Your local GP, we call it in this country, will have records. What else might we have? So please do post to the Q&A, or do please call out, or post to social media. Anything from the team? Where else? What other data might we use?
Records from the emergency helpline.
Yes. Telephone records. So there's the 111 service and the 999 service in this country. A similar thing. Google searches. If suddenly in Leicester or wherever it is, a lot of people are going onto Google typing, have I got COVID-19, or I have got a persistent tickly cough, that might be an indicator. Any more?
Like tracking of their GPS, their location.
Yeah, let's go for mobile phones or mobile devices. Nice one, Lippy. Any more?
Social chat.
Very good. Well done, Gareth. We'll make a data scientist out of you yet.
No way.
Okay. In the interest of time, I'm going to cut it here, but we can go on a lot further. And typically, this is the first step in any data science product, is thinking about where actually does that data live. Now, we're going to sidestep a very important step for the interest of speed and achievability, essentially. We are
One
not...
last one, Michael.
Go on.
Gov.uk as a source.
Yeah.
TV and radio, coming from the Q&A, media records.
Yeah, very good. Excellent. Good job. So we'll pause that one for there, but we've got some more interactivity coming. So we're going to sidestep an important thing. Once we've identified our data sources in the real world, we'd have to go and get that data. And that is a non-trivial task, but something we will explore on this specialism. So let's assume that we've done that. Our next task is to actually identify what bits in that data will be useful. Not everything in data will be useful. Typically, we need to spend a significant amount of time, what we call engineering that data, to create useful features. So I won't go through this word for word, but feature engineering is, the name for this process is feature engineering in data science. It's probably the most important part of the whole life cycle. It's going through that data and thinking what actually is going to be predictive in this. Let me think of a random example. If I was going to predict who will join the digital and data science specialism, some useful features might be, did they attend this session? Have they got an interest in data work outside of the course? Non-useful features will be things like age or gender. As it turns out, that is a very poor. You may assume, or in other places it's shown that the data science is more male-dominated. That has not been our experience. In our experience, gender has made no difference. We get as many females signing up for the specialism as males. So there's certain data items that are not predictive and certain ones that will be predictive. And our job in the data science process is to find the ones that are predictive. So let's go back to our list. I won't go through all of the list, but let's just pick out a couple of bits. So I'll go to Lipping's one. Actually, Lipping's one's probably the best one for me. Mobile phones and devices. So what can we gain from mobile phones and devices? What in that data feed would potentially be predictive? Well, one obvious example is the things like the apps that have been built that work on Bluetooth and see how close people have been together. We can also potentially look at how active people are. If people are mostly staying at home, the area is low risk, right? If people are out about shopping in busy shopping centres, if they are in close proximity to lots of other people, suddenly these are useful features. Suddenly we've got things that we can start to do something with. Let's try one other thing. So it might be, let's think about telephone records. Now, again, telephone records, if people are ringing, we have to always combine this with geolocation. Let's say we've had 100 calls in Coventry, or wherever we're modelling, right? If those 100 calls are evenly spread out through Coventry, that probably suggests there's not much of an issue. If 99 of those calls all come from the same street or from the same area of Coventry, that would suggest an outbreak. So it's taking that raw data and making useful features from it. Let's go to our next step. Now I'm going to very briefly go over the modelling approach. There is a lot of content we'll cover in particular in the CSP module and the DSML module that Lipping will talk about shortly, where we go into all of the different types of algorithms and data science approaches that we can apply to make our predictions. Here I'm going to give us just one simple choice that we're going to make collectively. Do we want to treat this as a classification problem or as a regression problem? So to explain these two terms, classification means our model is trying to predict if someone will be in a class or another. So let's say instead we are trying to predict student performance. So we can either predict whether the student will pass or fail, in which case this is a category prediction. Are they in a passing category or a failing category? This is a nominal value. There is no numbers behind that. It's a 1-0 kind of prediction. Or we could look to predict the exact mark that the student gets overall, in which case we have a numerical prediction. We would call that regression. So if we're predicting categories, we're doing classification. If we're predicting actual numbers, we're doing regression. What might classification look like in our app? If we're going to build an app for this, what would classification look like? What would we be predicting? Any ideas? Come on then, Lipping, you save the day. No? You're going to help me, Lipping?
Sorry.
Sorry,
I missed your question.
The question is, What would classification look like in this case? What would we be predicting if we were doing classification?
In this case, you mean the PMA or the module?
No, I mean our data product. In this case, I'll save you, Lipping. You were
Sorry.
thinking about your slides and not listening to me, weren't you? I know what's going on. So in our app that we're talking about, our classification algorithm will be predicting outbreak, yes or no. Is there going to be an outbreak in this area, yes or no? If we were building a regression, the question we'll be answering would be something like, how many people are infected or will be infected? Or what percentage of the population will be infected? Or how many people would need to go to regression? We need to go to hospital. So in the regression case, we're trying to predict an actual number. In the classification case, we're trying to predict a category. Outbreak, yes or no? Which is better in this case? What do we think? What do we think is better? Classification or regression for this problem? And why? Yeah, you see this 30-second delay is killing me, man. It's killing my flow. Any thoughts? What would you pick, Lipping?
I think it's classification.
I would probably go with classification as well.
Yeah.
The main thing is that classification is actually easier. It's easier to predict one of two categories than it is to predict the actual number. There's more randomness in predicting the actual number, but it's worth noting that both approaches will work. Let's go on to our penultimate stage. We now need to design some tests. We've built our model. How can we test how well our model works? How can we test how predictive and how accurate our work is? What might we do? How can we bring it out into the real world? Well, one thing we could do is just wait. We could just wait and see and try to predict outbreaks as they go across the country. What might be the downside to that? What might be the downside in just sort of waiting for real data to arrive? Any thoughts?
Shopping records for your previous question, I think.
Shopping records is good, yeah. If we suddenly get an uptake in antibacterial gel and tissues, maybe things are going wrong.
Whereas classification as well came in just after you said you'd move on.
Yeah, this time delay is killing me, man. Okay, what might be the issue of just going straight into testing in the real world? Any ideas on that one? It's not obvious. I'm giving you a tough class today. Well, the main problem as I would see it is this. If we're going to test our application in the real world, and that's going to be our main source of testing, we can do one of two things. If we observe an outbreak, if our model is predicting an outbreak, we either ignore that and see if an outbreak occurs, or we intervene. We try and stop the outbreak. If we try and stop the outbreak and succeed in doing it, we prove our model wrong, right? Our model actually hasn't predicted an outbreak because the outbreak didn't occur. We intervened before it happened, right? However, the other way round, if we don't interact, if we don't do anything after our model makes the prediction, we're actually behaving in quite an unethical way and in quite a dangerous way, right? Not taking action based on the prediction could lead to an outbreak. It could then lead into deaths. So testing in the real world is actually problematic in this case. What might we do instead? If we don't want to test in the real world, how might we test it? Now, one answer is historical data, but we probably used, as we showed here, historical data to help learn the model. So we probably already used that data. Anything else we might do? No ideas? I'm being very tough today, I know. And I know there's a delay as well. What I would probably do in this case is actually simulate data. Now, this might be surprising, but a lot of data science and machine learning and AI actually doesn't always work on real data. It works on data that we create. Now, we have enough data and enough scenarios out there of things happening in the world that we could actually create some artificial data and see what the model predicts. That allows us to apply it in a real world type setting, but also do it in a safe way where we don't have to intervene. Anyway, that's the hard bit over. Let's go to the last part. Once we have our prediction algorithm, what are we going to do with it? Well, how might we serve it to the world? Where might it be useful? What can we do with this prediction? Once we've got a model that is making these predictions, where should it go? The clues in the title, we're going to potentially build applications. But what applications should we build? Who would want to know about this information? Who would we want to inform? I'll wait my 30 seconds. Feels like a very long 30 seconds then. Anything coming in? What do you think, Armagan? How would you serve these predictions out to the world?
Sorry, I didn't get to your question because I was replying to a question in the chat.
I'll say it again.
Yeah.
So, how would we, once we've got a model that's making predictions, what might we do with it? How might we package it up and put an application for it? Who would be a customer?
Citizens from the chat, Michael.
Citizens, yeah. So how might we reach citizens?
Hospital and researchers. Hospital researchers coming in from the chat.
Great. Okay. So there's two different things we'd have to do there. Like if we wanted to do it for citizens, we probably need something like a mobile app, or we need a customer-facing website. If we want to reach hospitals and researchers, maybe we need an open data resource. Maybe we need an API so they can go and capture that data. Maybe we need things like dashboards, so the hospital can just look at the dashboard and see what the rate of infection is. Maybe we want to notify people. Maybe we want to be sending out emails or SMSs or push notifications into our users' phones. There's a whole heap of different products that will come out of our single prediction. So well done, my friends. Thanks for getting involved. I know the 10-minute delay was a killer, but that gives us a little taster of really that whole process. Now, I think not only is the COVID-19 case relevant because it's something that we're hearing a lot about, but it also gives us an insight into many important things about what it takes to do a good data science process. We've thought about these different steps in building a pseudo application, but thinking back to the lecture before that, thinking back to some of the things that have gone wrong in the way data has been presented, we can learn a lot from that. First of all, we can learn that you should never trust what you are told just by these single sources of truth. Things are moving very fast. Data changes all the time. Over-relying on a single source of data is very problematic. If you want to be a good data scientist, or if you want to be involved in a good data science process, it should be built on data from multiple places. And we saw that here. If we go back to this slide here, if we're just taking the data from one of these places, if we're just taking it from Google searches, we're only going to capture a small part of the problem. We need the plurality, the heterogeneity of data sources coming from lots of different places to really understand that problem. And that is a key lesson in data science. So be skeptical, use lots of data. Thirdly, we saw about how the communication of data can go wrong. Unless we are very careful with how we visualize and communicate data, unless we build these apps for our citizens in the right way, we will misinform people, we will make them panic when they don't need to, and we'll make them underestimate things when they should be more worried. It's very important that we get that communication done correctly. So hopefully that gives you a bit of a flavour of things. At that point, I am going to hand over to my better looking colleague, Liping Cheng.
Thank you, Michael.
Thank you.
Yeah, I'm going to share the screen.
I've just been asked to say while Liping sets up, this 30-second delay only occurs because of the Microsoft Live we're using. When we come to running classes, we don't get any of these delays. So just so you know.
Yeah, can you see my slides?
Yeah, you're good to go, Liping.
Yeah, okay. So next, thank you for Michael. It's very interesting observation about the statistics during COVID-19. And so next, I'm going to introduce some information about all the modules in digital and data science specialism. So basically, the same as other specialism, you will get 8 modules in this specialism. And first is e-business fundamentals and enterprise e-commerce system and digital marketing system and techniques. So these 3 modules, they are like business based, will give you some key concepts about like digital business and e-commerce and digital marketing. So it gets you to understand the business before you have start the data science or big data. So it's very important is that when you start doing kind of job like data science or data analytics, you still cannot do it without the business context. And even in the company, you will have a lot of meeting with your business colleagues and understand their requirements and also the business before you go and analyze your data or building the model. And then you will have big data analytics and visualization. So this is the first module. You will have knowledge about like big data or analytics and how to implement analytics in the real world. So it gets you to understand the data. And then is computational statistics with Python and data science machine learning. So these 2 modules are related to data science and get you to know some practice of data science. And the last 2 modules are cloud native computing and digital consultancy. So these 2, they are more project based. They are asking you to wrap up some digital solution for the company or for a project. So next, I will skip the first 3 modules because I think most of you will understand it, and I will have more information on the data related modules. The first one is big data analytics and visualization. So in this module, you will have lectures. Basically, there are 3 areas. One is big data supply chain, and also what kind of big data technology were involved, in what kind of technology were involved in the data storage or data extraction. And then you need to know how to transform data into insight. We will introduce different types of analytics and how you can apply them. And finally, you got data, you know how to analyze data. You also need to know how to deliver information. So we will teach you some techniques for you to deliver your insight. For example, like data visualization. So except for lectures, we also have some labs. So labs is what you can do. We will get you to do something. So you will learn by doing something, like you will use R to do data mining, and also you will use Tableau to do data visualization. So this software or language is what we think now is very popular in the career market as well. And we don't do it last year, but we are considering doing this year. We're going to get you to build database. So it will not be very complicated, but get you to try and understand database in a further step. And for the in-module assignment, you will be asked to do simulation. So you will have a real data set or data set from the real world, and then you will work as a group, and then you need to finish a business analytics report. And for your post-module assignment, it will be consultancy report. So in EBM, you will have a lot of PMA. They are very similar style. Is that you're going to finish this consulting report? Is that we will provide some background information or also some problems or questions, and then you need to provide a kind of situation analysis and also solution for a specific company or industry. So this is what we required in the PMA. And the second module is computational statistics with Python. So this will be the first module that will really do some coding and programming. So here we have lectures as well. So we will cover big data and statistics and some key methods of computational statistics like Bayesian or like Monte Carlo. And also you will do some data engineering, know how to build a data pipeline and how to do feature engineering like Michael mentioned before. And also you will know about like algorithm and some like computational complexity. And for your in-module assignment, because this one will get you to use Python. So before the module, we will give you a workbook. It's all about the Python basis. So you need to learn using the workbook. And after you come to the module, the first day you will have a Python test. It's time test, and it will be your in-module assessment. And except for that, we have a small part is that you will work as a group and do some project just from in each section of the lectures and do some presentation as a group. And for your post-module assignment, this one will be different from your other PMA because it will be combined with two parts. The first part is that you need to do some coding. So we will give you a data set, and for example, we'll get you to build a data pipeline, and also you can use the data set to building the pipeline. And also, except for that, we will give you some questions. So you need to finish a report to answer the questions so we can check whether you understand some key concept from the lectures or not. And the next one is data science and machine learning. So it's kind of like continuous of the last module, CSP. So in this part, you will understand data science project like Michael covered before, the whole process of data science project, and you get to know machine learning algorithm and also deep learning as well. And for your in-module assignment, it would be more like a hands-on experience. You will be asked to work as a group to do on a data science project. So the same, we will give you the data set, and you as a group need to figure out how to deal with the data and how to build the model and assess the model. And then you need to come back to us and to do some kind of like summary of your project and how your model was in the presentation. For the PMA, it's very similar to CSP, also coding and report. The coding part is very similar to what you have done in the in-module assignment. So you will have a data set and also do the data science project. And the report is also similar to the CSP one. And next is cloud native computing. So like Michael mentioned just now, you learn how to build up the model in data science module, and then you need to deploy the model, or maybe you need to build an application to deploy the model. So here the cloud native communication is all about like the build how you're going to manage a project or building an app, or how you're going to deploy an application in the real world. So we will cover like project management in the old world and also in the future, and also different ways to do the project management. And we cover agile and like DevOps, and we also cover the cloud native computing practice. And maybe we will cover like how we do data science in cloud as well. And except for the lectures, we have the workshop. The workshop, we will get you to try doing cloud native computing in AWS. So here we'll still provide you a workbook. So you with the workbook, and you can try and do it, and step by step, it will not be that hard, and we will be there help you as well. And for the in-module assignment, it would be a project. So you were given a project and then you need to collect requirements, and then to finish the project, it would be about like building an app or some kind of like this kind of project. And then you provide your solution in the presentation, the last day of the module. And for the PMA, it is similar to other modules as well. It's consulting report. It's all run like cloud native computing practice and how you evaluate different practice in cloud native computing. And the last one is digital consultancy. So here you will understand how what is business process and how to do business analysis, and then you need to know how to determine the solution space using what you have got from the business analysis or like process mapping. And here it would be like kind of so for the in-module assignment, it is also very practical. So we will invite some real company, you will get a real client, and you will have the opportunity to interview them, to understand their requirements, and then you need to provide digital solution for them. So this solution, you may use something that you learned from the previous modules, like in big data, digital marketing, e-commerce, or like data science module, and then you can provide a kind of like complete solution to the real client. And for the PMA, similarly, still the consulting report will give you a kind of context and like questions for you to figure out the solution. So this is all the modules. And I think after you hear all the introduction, and also I can see in the chat, a lot of people are asking the same question, is that should I choose specialism? Maybe you just, you want to choose, but you are afraid of something. Like some typical questions is that I don't have any programming background. Should I choose this specialism? Or I don't have any statistics background. Should I choose? And for these two questions, my answer is yes. If you don't have, it doesn't matter. But I have to say you need to know some basic stuff. If just know nothing, maybe it would be a problem. But I believe most of you may learn math or statistics for your undergraduate, even you are not getting like statistic degree. But for the programming background, I think it is not necessary. It would be good if you have, but it's not necessary to equip if you want to choose this specialism. Because for me, I also don't have any programming background, but I still can do it later. But just you need to put more efforts. But for the third question is that I don't have much interest, but I think it would be useful for my career should I choose. For this one, I have some doubt on it. If you don't have any interest, you just feeling it's very useful, I think you should be cautious, because it will be a very hard year for you if you don't have any interest. You will need to spend hours doing something that you don't like, and you will feeling you are always like struggling. So my answer to it is that you need to have a huge interest in specialism, in data science or big data, or even you like math a lot, and you also like to dealing with data, you like to solve problem using data. If you have this kind of passion or interest, and I think you also have the motivation and you are prepared to choose this specialism. I reflect back to my experience. Actually, for my undergraduate, I learned international business management, and also business English is nothing with to do with programming or statistics. And after I do some job related to data analytics, so for my perspective, I'm really interested in dealing with data. And I still can remember like the first day when we are going to choose specialism, I asked Michael whether I should choose this specialism or not. Actually, the same question as you guys. And he just tell me like interest. So I still remember it. And I think it's very important. And if I reflect back the previous year I'm starting here, I think it just motivate me to do a lot of stuff, because I will spend hours doing some programming, and it take a lot of time. And also at the very beginning, I cannot understand a lot of stuff, and I need to do some extra work except for the lectures, and I do some like tutorials using some materials, or checking a lot of like blog or report or articles to equip myself to understand more stuff. So if you are really interested in that, I think a lot of difficulties can be overcome. So this is, I think, is the key thing that for you to choose this specialism. And another question I think is what you will care about is whether you can be a data scientist after you finish studying. My answer is yes. It's possible that you can become a data scientist, but generally you will maybe from the beginner level, and then you will have made progress in your career. So I have some example, like my previous classmate, Area. She didn't have any background in data science before she come to EBM. She's learning human resources management for her undergraduate, and after she got some more experience also just on some business or like very general operation work. But she is learning like in EBM, and finally she got the job like doing business intelligence in SAP, and she also built an app like for like different product, different like data product. So it's possible that if you are really interested in that, but I know like she is saying she is interested in that, and also she put a lot of efforts. She do a lot of other courses as well before she go for interview. And also I think is that if you are really into it, and you will feel confident, and if you are being confident, I think is how you get the job in the job market, because you believe you can do it. But actually for the company, if you just graduate, they don't expect that much, like you will be like an expert. What they require, just you understand some key concept, and all this key concept is what we told you like in the module or in the lectures. So you just need to understand some key things, and then you equip yourself. And for the software or programming language, I think the practice is very important. If you can take some time to do practice, and also to do some just take some time to do it before the interview, I think everything can be done. So it's possible that you can do something just closely related to data science. But you will ask, can I only be data scientist? The answer is no. You can also do something else, because like our specialism is called digital and data science. So it's not only data science, it's also like part of digital business as well. So you can be more business oriented. So you can do like business analytics, or like in my previous company, based on my observation, you can do a lot of stuff like if you are really interested in product, you can do product manager, because now we have like different data products in the company as well. Even some general product, they also want some product manager to understand data as well. And also you can be like in the operation part, like user growth analyst, or you can do a lot of this kind of stuff. And also like if you are in the business team, you can do more like business analysis. So all these jobs are available for you. And also you can do some basic stuff if you are really not confident about that. So there are a lot of different chances for you to do it. Just in this module, after you choose this specialism, I think the main thing is that you need to figure out which area is the one you are really interested in. Maybe some of you will be interested in data engineering, like you are a lot into database, and then you can just put more efforts on it. And some of you may more into algorithm or machine learning, and you can spend more time on it. Or some of you're just more into like data analytics and data visualization, and then you can put more efforts on it. So it's just up to you what kind of, where is your interest, and then you can have more target like area, and then you can put efforts just in that area if you want to look for specific jobs. So this is all the sections about, and if you still have some concerns or other questions, you can ask.
Yeah, I just wanted to quickly pick up on Lipping's point. So we've seen quite a few students now having done this specialism, including Lipping herself, and it's not necessarily the best predictor of success in the course or even in getting a job afterwards. Is not necessarily the background you have prior to doing this specialism. So I myself, I came from film studies as a first degree, and as Lipping said, she came from a more general business degree background. It is absolutely the level of interest and the level of motivation you have to look at it. In reality, if you are not interested in the thing, it is harder to get through a digital and data science specialism than it is to get through, say, a digital marketing specialism. No offence, Gareth. A lot of the topics you will cover in something like digital marketing are general interest that everyone can relate to and everyone will be able to enjoy. So if you are going to pick the digital and data science specialism, the most important thing I'd impress upon you is ensure that you have that level of interest, because that's what you'll need to get through the course. You don't need to have an MSc in statistics or a bachelor's degree in statistics or a bachelor's degree in computer science. Absolutely, you can learn the necessary skills in the course and beyond the course, as Lipping says. And we've seen plenty of students go off and do that. What you do need to be, though, is interested in programming, in the sort of solutions, in building the kind of products we walk through today. If you have that level of interest, that will give you the necessary motivation to be able to be successful in this space. I've worked in all sorts of different areas, including digital marketing. Data science for me is by far the most enjoyable part.
Yeah, and because for example, when you're dealing with data, the data would be very messy, and you need to look at it and spending a lot of time. So if you are not interested in it, you will feeling impatient and also feeling just exhausted.
Yeah, you have to be stubborn. That's what you have to be.
Yeah.
Place. You have to be absolutely determined to get the truth and be stubborn enough to dig that truth, do what's required to get there. And that's true of the course, but that's true of the job as well. But also to pick up on what Lipping was saying, every company or most big companies now are building data science capabilities, but a data science capability is bigger than just hiring data scientists. You need people who can manage the data. You need people who can do the business analysis parts, as Lipping says. You need people who are experts in visualization and dashboards and reporting. And we know that this specialism would suit you if you want to go in any of those directions. But it's about being interested in the data science process overall, essentially.
Are we taking questions now, Michael?
We can take questions now, I think, yes.
Yeah, just a couple on the online delivery just popped in at the end, which would be good to talk about. A bit concerned about the module delivery on Teams, with students using Teams unable to watch the live network delay, slides unclear. Will we still use this online method for formal courses?
Okay, so I think I don't know if that relates to what they've had in this experience right now, or something else. But the feedback we've had from students, many of which are in China, is that the slides are coming through fine in the format we've been running classes in. I've not heard anything to the contrary of that. If you are doing an online class anywhere, it is important that you follow steps to maximize your internet connectivity, and we can certainly advise on that. Little things like trying to be as close to the router as possible, and some things like that can be done, and that would apply to any online delivery mechanism. However, we've not really had that issue from students when we've run classes. I think that's fair to say, isn't it, everyone?
Yeah, and a question about, so like, just then we couldn't see you while you were speaking, Michael, answering the question. That's the restriction of this Microsoft Teams live event that we're using at the moment. So during class, you'll see all the teachers, all the tutors, they'll have all their videos on. It's a bit of quite a different experience to this session that you've seen today.
Yeah, totally. Down your glasses. Microsoft Live has some advantages for what we're doing right now, particularly because we can invite you all in as anonymous, essentially. But I think in the actual delivery of a class, it is far superior to use the normal version of Microsoft Teams. And when we have used the Microsoft Teams, we've run classes where some students are in the Americas and some students are in the Far East, in China and neighbouring countries. And it has worked all across there. Well, very few issues at all of a technical nature. And the ones where we have had issues, we've been able to resolve them by following some of the usual problem shooting steps. Now, obviously, we hope that the amount of use of Microsoft Teams and reliance on online is going to be at a minimum. That should be clear, though. There's a lot of things outside of our control in that regard. We are watching what happens in the world, as everyone is. And obviously, first priority is going to be making sure everyone stays healthy and we avoid any issues. So we can't rule out that we have to do a large portion online. But the hope is that we're moving towards normality now, and it will be less reliant on Microsoft Teams next year.
And following on.
And just one last thing on that, sorry. We have looked at lots of different platforms for this delivery mechanism. We have no great love for Microsoft Teams, and if we felt that Microsoft Teams wasn't the best, we would use something else. But the work that we did, and obviously this is an area we all work in, actually found that Microsoft Teams worked the best. If that stops being the case, though, we're quite happy to change out and use whatever tool works best.
And following on from that, is there anything you'd like to add around the presentations and module work of labs?
Yeah, I mean, I think I commented in the chat. I mean, the labs actually, I said the intention is that all of that work will be in a face-to-face environment. The labs and student presentations will all be in the face-to-face environment. If that can't be the case, for whatever may come round the corner, our experience from this year is the labs worked absolutely fine. I don't know about you, Lippy, but I didn't feel there was any really online to offline. In fact, that was one of the bits that I thought worked better online in comparison to offline compared to most things. Discussion type sessions, I think, are the ones actually where you want to be face-to-face moreover, because the labs, we ran it all via AWS Cloud. We were able to log into your session, we were able to join your groups and see your code running. We can fix problems live as and when we need to. There was little to no drop off in moving online with that. Student presentations, again, I'd rather student presentations face-to-face, but it's something we seem to adapt to quite well, and the student presentations were delivered online. The key point I flagged in the comment is that when we're doing these sessions, we're going to do them live, irrespective of whether it's face-to-face or online. So you will be getting live feedback, you will be getting live questions the experience is not as different as you may think.
Yeah, I think it will be similar because like this year, a lot of students, they also doing presentation in Teams. They're doing very well. And if you really enjoyed it and you can open your video, you can show yourself and you can show everything and share your screen. And yeah, I think it will be similar.
Yeah.
But maybe just they need you to more engagement, like in the group discussion. So yeah, because you cannot see each other, so you need to be more active.
Yeah, there's definitely a requirement to almost work to make sure to regulate yourself and make sure you're working hard in that regard. It's when you're face to face with someone, you feel embarrassed not doing the work, right? So that the situation regulates you automatically. So more goes on you to be disciplined and regulated in organising it, but I think it can certainly work. And the other last point I just make on that, I spend most of the presentations I do today, even before all this, are online presentations. Most of the teamwork and group work and consultancy projects I've done have been heavily online and via tools like Teams, essentially. This is something that business wants you to be good at. So being good at doing an online presentation is a key skill to have in today's economy.
Again, following on from that, are there any learning activities offline for the first term? I'm considering if I need to go to the UK for the first term.
Yeah, but by definition, we the decision at WMG is to not make it a requirement to be on campus in the first term. So there's nothing you have to do in person in the first time, because we understand it is going to be difficult for everyone to turn up in October like you would normally. So there's nothing you have to do offline, essentially, in the first term. However, there are several things that we will put on offline. You know, you wouldn't just be sitting in your room doing nothing. If you come to campus in October, we would actively encourage that where it is safe to do so and where it is possible to do so. But anything that is marked, or anything that bears marks, we don't want there to be a disparity between the people doing it online and offline. We don't want people working online to feel they are disadvantaged or that they got less marks because they were working through no fault of their own online. At the same time, there will be learning activities, there will be opportunity to meet potential supervisors and attend sessions that will be run face-to-face. So it is not necessary, the answer to your question is absolutely not necessary to arrive in the first time. If you can arrive in the first term and you're happy to do so, there are things you can engage with for sure. And more will be released in terms of what that will look like. But certainly we don't want people who can't attend to feel disadvantaged.
We plan on doing another session in August about what term one will look like. So keep tuned for that. We got a question from WeChat. We've had some students offer holders have had some difficulty getting in through the joining instructions, or the video didn't play smoothly, and they're worried about the course experience.
Well, then, Mark, you can answer that.
Well, we've been running online modules since March, when the UK went into lockdown, and that was with students all over the world, in China and Indonesia as well, in Thailand, and it worked really well, really successfully. If there were issues, we encouraged students to get near their router, make sure we just got Teams running, they weren't downloading anything else, making sure their video is off and they're using it when needed. So really kind of optimizing that bandwidth, really. But yeah, we've got a lot of experience doing this now, so we've had no problems at all. We know Teams works really well for us. Okay, moving on. Michael will send through some recommended reading.
Lipping, read it.
Oh, Lipping?
Yeah.
Oh, no.
I'm volunteering.
Yeah, you can email me. Like if you want to know like statistics or data science, I can give you some recommendations. Just
I thought Lipping was posting if you email Michael Mortensen at Warwick then.
yeah, or email Michael.
Okay.
So Any more questions? Python is the main language, isn't it?
Yeah, but Python.
Yes.
When I first started in this space, the debate was always, should I learn Python or R? Today, Python is the number one language by a long way. It's also the language I prefer anyway, and in many ways, it's an easier language to learn. But that is the language that we'll promote on this, and that's the one we'll in depth.
Yeah.
Okay, question in from WeChat. I decided to choose data science as my specialism. Could you please give me some suggestions how to prepare for my master's study?
Okay, drink lots of coffee. Well, as I say, we would happily, Lipin will happily share with you some reading if you're interested in doing that. To be honest with you, I think the main thing would be to just sort of get out there and start to engage with that community. One of the great things about doing anything in e-business, and digital and data science is no exception, is that actually that lives online in most cases. So all of the stuff I've covered with today was stuff that is just online or in the mass media or on TV. So just starting to engage with the world of data and playing around with those things would be, starting to think in terms of data would be the way I would recommend starting. But we are primarily designed to be self-contained, so there is no prerequisite learning to do before arrival.
And one of the most common questions, do we need any computer programming knowledge for this?
For programming knowledge, and a lot of students are coming out any programming. We teach from the ground up, essentially. And there is an expectation you'd have a basic level of statistics equivalent to having done, as Lipin said, an undergraduate module. So a module in statistics. So you can cover things like mean, standard deviation, linear regression, understanding what a statistical distribution is. It doesn't have to be much more advanced than that, but a basic understanding of how maths works. Any experience you do have is obviously advantageous, but there is no expectation of prior programming experience.
Drink a lot of coffee. Yes, that came in from WeChat. I think you covered everything. And the one about PhDs you've explained, Michael. But yeah, it's a great opportunity for you to go on further study.
And let's say, this is my response. In a lot of industries, a PhD doesn't necessarily help you. Having a PhD in digital marketing won't necessarily get you any better job opportunities in digital marketing. Obviously, it's good for a career in academia, but not really in digital marketing. But data science actually is one of the exceptions to that rule, where it really does help you find clients or get jobs in this sector, which is the reason why I went on and did my PhD.
Okay.
And hers as well, right?
Yeah. As most of the questions covered, top recommendation: drink a lot of coffee. Do you have any more slides, or is that the end of the?
I think there was there a couple?
Yeah. I can share?
Yeah.
Or you can share.
I'll put you live. Liping. Share your screen, Liping.
Yeah. Oh, sorry.
Just show.
About the upcoming events, right?
Yep, you're going live, Liping. You're live.
Yeah. So we have some upcoming events. If you are also interested in other specialism and you want to make decision between different, and you can join as well. Like tomorrow we have digital consultancy specialism, and the day after we have digital marketing and e-commerce. And then in 28th of July, we have a section that we will share some student experience and how you will, as a e-business management, how's your life in the UK or at Warwick. And if you and also we have some previous event recording for the specialism selection before I think you attended can click the link. And also for this section, we also recorded. You can just click the same link and then you can watch the recording. And how to access the recording or how to join the event, you can just click this link, and we have the page to introduce all the sections and upcoming events and how to join the live Teams live event. Yeah, so that's all.
Thank you. So, if you missed any of this or would like to rewatch it, please revisit the link, and they got sent out, and you'll be able to watch the whole recording again. Lipping will send out the slides into WeChat and WhatsApp. Please join those groups if you already haven't.
Just a small point that I want to make. I've been reading the comments. There's a lot about coffee. Just wanted to let you guys know that on campus we have free coffee for students, all of them.
It's not as good as coffee at home though. Oh, we're good. I've got a really expensive coffee machine.
Yeah. I don't have a machine, but I got expensive coffee.
It's an investment. It's worth doing. It's worth doing it. You know, you want to see it working at home. You need to invest in the right products, right?
Definitely. So yeah, next session tomorrow at 2:00 with digital consultancy with James Pennington.
Yeah.
And Shah, are you going to be there?
Yeah, I think she's here.
Shah
Yes, I will be there.
Yes.
Yeah.
So
It's the
find
best-
out more.
Best specialism.
Find
Yeah.
out more.
No maths. No maths. No statistics.
So come and find out more about that specialism. Any questions, feel free to contact us via email or any of the many different social media channels that we've got. And thank you all for coming and attending. We hope it helped make a decision on why data science is for you or not for you.
Yeah, and if you want more information or you want to have a chat, you can email me or anytime you want, if still cannot decide it.
Okay, well, we'll finish it there then. So thank you very much.
Thank you.
Okay, and see you all soon.
See you all soon.
Bye.